You finish a new, intense workout. You feel accomplished, tired, but fine. The next morning, you wake up expecting the price for your effort, but there's almost nothing. It's the day after that, a full 48 hours later, when the real bill arrives. Suddenly, walking down a simple flight of stairs feels like a monumental task. This strange delayed reaction pain has a name: delayed onset muscle soreness, or DOMS. For decades, the simple explanation was microscopic tears in your muscles. While that's part of the story, it completely fails to explain the most interesting part: the delay. Why don't you feel the pain when the damage actually occurs? The pain isn't from the tears themselves. It's from the cleanup operation. When muscle fibers are stretched under load, especially during eccentric movements like lowering a weight, their internal structure is disrupted. The delicate Z-discs that anchor muscle filaments are pulled apart. This isn't just a simple rip, it's a cellular crisis. Organelles like mitochondria are damaged, and the cell membrane becomes permeable. This causes the cell to leak its insides into the space between fibers. Molecules that should always be inside a cell, like ATP or fragments of DNA, are now outside. Your immune system sees this and correctly identifies it not as an injury, but as a mess. These molecules are what scientists call DAMPs, damage-associated molecular patterns. They are the silent alarm. This alarm isn't answered instantly. Your body's emergency response has its own schedule. Within a few hours, the first responders arrive: neutrophils. Think of them as a SWAT team. They rush to the site of damage and begin breaking down debris. But they are indiscriminate, releasing reactive oxygen species that can cause collateral damage to healthy neighboring tissue. They do their job and then die off. The real conductors of this orchestra arrive much later, between 24 and 48 hours after the workout. These are the macrophages. The peak of your pain perfectly coincides with the peak population of these specific immune cells at the damage site. Their arrival explains the delay. But not all macrophages are the same. Initially, the site is dominated by pro-inflammatory M1 macrophages. Their job is to continue the cleanup, engulfing dead cell fragments and releasing signals called cytokines. These cytokines, like tumor necrosis factor alpha and interleukin-6, are powerful chemicals that create an inflammatory environment. This is a necessary step, but it's also what screams pain to your nervous system. Then something remarkable happens. After about 48 to 72 hours, the macrophage population begins to shift. They polarize into a different type, the anti-inflammatory M2 macrophage. These cells release signals that calm the inflammation and actively promote tissue repair by activating muscle stem cells. Your relief from soreness is the direct result of this cellular switch from demolition crew to construction crew. So how does a chemical soup of cytokines actually feel like pain? It's not that these chemicals are simply pushing a pain button. They're changing the button itself. Your muscles are filled with nerve endings called nociceptors, which are designed to detect potentially damaging stimuli. The inflammatory chemicals like bradykinin and prostaglandins don't just activate these nerves, they sensitize them. They effectively lower the nerve's firing threshold. This means a stimulus that is normally perfectly harmless, like the simple stretching of a muscle when you walk or sit down, is now enough to make that nerve fire a strong pain signal to your brain. Your muscle isn't re-tearing when you walk down the stairs. Your safety sensors have just been turned up to maximum sensitivity. This entire painful, inflammatory process is not a bug. It is a feature. It is the essential signal for adaptation. Lining the outside of your muscle fibers are dormant stem cells called satellite cells. They are waiting for a crisis. The signals released by the M2 macrophages, along with the mechanical strain itself, are the wake-up call. Once activated, these satellite cells begin to multiply. Some of them then travel to the site of the injury and fuse with the existing muscle fiber, donating their nuclei and cellular machinery to patch the damage. This not only repairs the fiber, but can make it slightly bigger and more resilient than it was before. This is the physical basis of getting stronger. This brings up a fascinating paradox. If the inflammatory cascade is what signals your muscles to repair and grow stronger, what happens when you try to block it? Many of us reach for an ice pack or an anti-inflammatory pill like ibuprofen to reduce the soreness. These treatments work by reducing that very inflammation. Ice constricts blood vessels, limiting the flow of immune cells to the area. NSAIDs directly inhibit the production of inflammatory molecules like prostaglandins. Several studies suggest that while this can reduce short-term pain, chronic, high-dose use of anti-inflammatories after exercise may actually blunt the long-term gains in muscle mass and strength. You might be sacrificing future adaptation for present comfort. The pain, it turns out, might be the point. This delayed response to cellular damage isn't unique to your muscles. Consider a sunburn. You spend a day in the sun, feel fine, and then 24 hours later, your skin is bright red, hot, and painful. The UV radiation triggered a process of programmed cell death in your skin cells, but it takes time for them to die and be recognized as damaged. Once they are, your body initiates the exact same inflammatory cascade. Neutrophils, followed by macrophages, to clear away the dead cells. The soreness you feel from exercise and the pain from a sunburn are, at a deep biological level, echoes of the same fundamental program, a carefully timed, meticulously organized response to cellular crisis, designed not just to clean up a mess, but to rebuild stronger in its wake. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.